Normal distributions and finding values. Finding values given a probability or given an area. So if you're given a probability or an area, and we will be asked to find the value of the random variable. So a key note is that percentile notation will use a capital P with the lower script letter number. And in this case, we have capital P 10. And what that means is it's 10% or 10 percentile or 0.10. So it's important to be able to understand the abbreviations for percentile notation. So when you're finding the z-score, if you were to choose to use the table in your textbook, the way you would do it is you would take the area that's given, and in this case it's 0.9973, and you would look in the body of the standard normal table. And then you would have to find that value, and then you'll connect it with the z-score that is associated with it. So in this case, you see that we have the 2.7, which is the z, and then you find the hundredths place, which is that 0.08, and you put it together. So the z-score for this 0.9973 area would be 2.78. Now a key note is sometimes you won't have the exact area in the table, so you'll use the value closest to the area you have. So to do this in the calculator, whether you have the TI-83 or 84, you have to use your second key and VARS button. Notice that above the VARS button you have that menu, the DISTR, which represents distribution, and we're in the normal distribution, so that's what the menu option would be. And then you want to choose number 3, which is the inverse of norm, meaning we're given the area and we want to find the z-score versus having the z-score and wanting to find the area. So in this case, you're going to enter through 3, and if you have the 84, you'll see the word area, and notice that our mean is 0 and our standard deviation is 1 because it's a standard normal distribution. And on a standard normal distribution, our mean is 0 and the standard deviation is 1. Now for the TI-83, you'll just see the INV norm, and then you would put in the value of the area and hit enter, and it will give you the z-score. Now remember, when you're doing a z-score, the z-score is only 2 decimal places, just like it is on the grid. There are 2 exceptions, and it's important that you notice what their 2 exceptions are, and they are on the table. And that is for the 90 percentile, and I think it's 98. So now be careful, because when we're working with finding the z-score for a percentage on a distribution area that is to the right, keep in mind that when we're working with distribution, the area is always, or the z-score is always based on the area going to the left. So if we want to find the z-score for the area of, or the percentage of 49, you have to convert it to a decimal, and it's getting shaded to the right, which means I need to find what the area would be shaded to the left to find the z-score associated with this. So to find that area, I would do 1 minus the 4.09, and I would find the area to be 0.5910. And then you would need to look this up in the body of the table and connect it with the corresponding z-score. So in this case, you would end up with the z-score of 0.23. So if we were going to do this in the calculator, it's the same process that we did before. You're going to use the second VARS button to get to that distribution menu, and you want to choose the inverse norm. And in the inverse norm, you're going to have to do 1 minus whatever the area is to the right. And you can put it right in this menu, and it will get you the Z value associated with it. So our calculators will do the conversion for us. So now when you see find the Z-score for a corresponding percentile and you have it with the abbreviation of P and 5, be careful here because this is 5%, not 50%. So make sure that when you're looking at these percentiles that you know what the area or what the decimal would be that you're looking up. So again, you could put this in your calculator or you can look it up on the chart, and this is one of those special cases where we have a value that is directly between two Z-scores. So what you would do here is you would put that 005 on the end, so that instead of it being a 2 decimal place, it would go 3 decimal places. So the Z-score would be a negative 1.645, and that's for 5%, and for a 90% or 95%, it would be a positive 1.645. Pause and try. You should have gotten a Z-score of a negative 0.81. Pause and try. You should have gotten a Z-score of 2.39. Pause and try. You should have gotten a Z-score of a negative 1.04. So now some key notes and cautions, the difference between Z-scores and areas. So you don't want to confuse Z-scores and areas. Z-scores get us an area. So it's really important that you know that there's differences between the two. The Z-scores are the distance along the horizontal. Remember, the Z-scores in the center is 0, and on both ends it's negative 1 and 1 and negative 2 and 2. So you want to make sure that you know what you're looking at. The Z-score is on the horizontal axis. The areas are the region under the curve. The region under the curve that's shaded from a particular Z-score. And the table lists the Z-scores in the left column and across the top row, but areas are found in the body of the table. So the Z-scores, again, if you were to use the table, you would see it along the outside of the table, but the area is in the body. Now we will be using our calculators most of the time, so if we were doing the Z-score, we would use option 2 in the distribution menu, and when we're doing the area to find the Z-score, we would use option 3 in the distribution menu. Another key notion is Z-scores must be negative whenever it is located on the left half of the normal distribution. So when you're looking here, if we have an area that's less than 50% or 0.5000, we're going to have a negative Z-score. And lastly, areas or probabilities, again, areas and probabilities are the same, are positive or 0 values, but they're never negative. So our Z-score can be negative, but you'll never have a probability with a negative value. So when we want to transform a Z-score to an X value or a random variable, the formula to transform a standard Z-score to a data value X in a given population is this. We have X will equal our mean or mu plus the Z-score times the standard deviation. If the area is given, you'll need to find the z-score, or just simply use the calculator, the TI-83 or 84, and I will be showing you how to do that. So here's an example. Veterinarian records the weight of a cat treated at a clinic. The weights are normally distributed with a mean of 9 pounds and a standard deviation of 2. It wants me to find the weights of an X corresponding to the z-score of 1.58. So in order to do this, I'm going to need to use that formula to convert the information into a data value. So in order to find this, I'm going to be using this formula. The random variable x will equal our mean plus our z times our standard deviation. So in this case, I'm just pulling out the information. Mean is 9, standard deviation is 2. They gave me a z value of 1.98. I'm plugging it into the formula and I'm evaluating. So in this case, my random variable, or my x value, would be 12.16 pounds. Pause and try. So again, you're given everything you need, so you're going to calculate it out, and you should have gotten 145.60. And we're talking dollars, so you want to make sure that you answer it in dollars. This next example, when designing equipment, one common criteria is to use a design that accommodates 95% of the population. So it wants us to design something that incorporates or accommodates 95% of the population. Assume that the heights of women are normally distributed with a mean of 63.7 inches and a standard deviation of 2.9 inches. What is the maximum allowed height? Now, when we're talking about maximum allowed height, and because it's talking about 95 percentile, that would be our area. So I'm using this formula, and in this case I'm given the area. So I have my mean, which is that 63.7, the standard deviation, which is that 2.9, but because they're saying 95 percentile, percentiles associated with area. So I'm given the area in this case, and the area is 0.95, and it includes 0.95, so therefore it would be going from shading to the left. So to find this, I can simply convert the 0.95 to a z-score by using the calculator or looking it up in the table, and then plug everything into the formula and evaluate and get my answer. So I would end up with this 68.47. The second option, and this is the option I prefer, is to use the calculator, and you're going to go into that distribution menu. The second bar is that distribution, and you're going to choose number 3. Now in number 3, if you have the older calculator, you'll put in the area, and in this case it's that 0.95, the mean and the standard deviation, and you hit enter, and you will get the X value that is associated with that information. Now if you have a newer calculator, you're going to have the area, and then you're going to have to change that mean from 0 to the 63.7 and the standard deviation from 1 to the 2.9. And then you'll hit enter, and it will give you the 68.47. Pause and try. So you should have gotten the 71.551 inches. This next example, we have scores for the California Peace Officer Standards and Training Test are normally distributed with a mean of 50 and a standard deviation of 10. An agency will only hire applicants with scores in the top 10%. What is the lowest score you can earn and still be eligible to be hired by the agency? So the key information here is I have my mean of 50 and my standard deviation of 10. But in order to find that lowest score, I have to understand what it means by the top 10%. The top 10% on my normal distribution would be shaded to the right. So if I were to do this in the calculator, it's very important that when you do this, you should do the 1 minus that 0.10% to get the appropriate z-score or the right area. So when you're doing this, it's 1 minus that 10%, and then you'll put in the mean and the standard deviation, and you'll end up with the actual lowest test score you could earn would be 62.8 or 63 if you were to round. So again, it's interpreting what the words are saying. Top 10% would be shaded to the right. Therefore, when you're trying to find that z-score or you're plugging it into the calculator, you need to use that 1 minus the area because it's not going to the left. Very important to make that connection early on. This next one is the weights of bags of chips for a vending machine are normally distributed with a mean of 1.25 ounces and a standard deviation of 0.1 ounces. Bags that have weights in the lower 8% are too light and will not work in the machine. What is the least a bag of chips can weigh and still work in the machine? So now you have to understand the information that's given. So you have your mean and your standard deviation, and it's saying the lower 8%. Notice the lower 8% would be shaded to the left, and that is in standard form. So you can use the calculator to do this, and when you do that, you're plugging in that 8%, which would be 0.08. Put in the mean, the standard deviation, and you'll find that the weight, that the least weight that a bag can weigh is 1.11. So that is really important to understand what it's asking when you're finding these values. Pause and try. A key thing is that top 25%, you should have gotten the data value of 11.39 pounds. And then the bottom 15%, you should have gotten 6.6 pounds. Pause and try. So now this is a mixed problem. The first thing it's asking me to do is find the probability of pregnancy lasting 370 days or longer. Well, what that is, it's probability. Probability of a random variable being greater than 307. So in this case, you would find that probability by putting it into that second vars and choosing number 2 button and plugging in all the information. And remember, when it's greater than, you put the number in the lower limit, and in the upper limit you use that positive 10,000. Change the mean to 266 and the standard deviation to 15, and then you would get that our probability would be 0.0031. Now the next part, if the length of pregnancy is in the lowest 3%, this is similar to what we did in the previous exercise. So the lowest 3%, you would end up with a length of 238 days. So now we're going to work with the normal approximation to a binomial. The normal distribution is used to approximate the binomial distribution when it would be impractical to use the binomial distribution to find a probability. That is, that our n value, or our sample size, is large or on an interval. The key here is you're going to have to first test these two scenarios. If your sample size times your probability of success is greater than or equal to 5, and the sample size times the percent of failure greater than or equal to 5, then the probability random variable x is approximately normal with a mean And remember, you'll have to find the mean with n times your probability of success and the standard deviation, where you would take your n times your p times your q and square root that value. With a normal distribution for a binomial, you will need to do a correction for continuity, because when we have binomial probability, it's based on an exact value. Working in normal distribution, we work with intervals. So when you use a continuous normal distribution to approximate a binomial probability, you need to move 0.5 units to the left and right of the midpoint to include all possible x values in the interval. And this is the correction for the continuity. So you see a picture here of the exact value of probability. So the probability would equal some value. But when we're working in normal distribution, we're working in interval notation. So it's really important that you do this corrected continuity interval before you find the probability. And a key note here is, because the binomial distribution is a discrete probability distribution, whereas normal distribution is a continuous or on an interval. So here is the continuity correction factor table. If you have exactly a value, then the interval for the normal distribution would be the exact value minus 0.5 plus 0.5. So it would be between those two values. If you have the wording at most some value, then you would need to make sure that that value was included, so you would add 0.5 in the interval. And at most means it would be x is less than the value plus the 0.5. Fewer than, you would subtract 0.5, it would be less than the x random variable and the value minus 0.5. At least would be the x is greater than, and you would need to subtract the 0.5 from the value. And more than, your probability would be greater than, and you would add the 0.5. So for an example, use the correction for continuity to convert the binomial intervals to a normal distribution interval. So we have a probability of getting at least 158 successes. Well, at least means that we also need to make sure in our interval that it includes it. And at least means that it's going to include it and get larger. So our probability, or our interval notation, would be p, the random variable, greater than, and you would subtract 0.5 from that 158. So the corrected interval here would be x is greater than 157.5. So the corrected interval is very important. The wording will help us to write the probability statement. This next one, we want the probability of getting less than 63. So I want to write the probability format, and in this, because it's less than, I'm taking 0.5 away from the 63. So my probability, or my corrected interval, would be x is less than 62.5. Pause and try. At most means that it includes it, so you need to add the 0.5 to the corrected interval. Pause and try. At least means that it includes it, so you need to subtract the 0.5 from the 158. So the guidelines when using a normal distribution to approximate a binomial probability, the first thing you're going to need to do is verify that the binomial distribution applies. So when you're doing this, you want to identify your n, your p, and your q. So remember, the n is the sample size, the p will be percentage of success, and the q is percentage of failure. To find the q, you take 1 minus p, and you will have your q value. Determine if you can use the normal distribution to approximate the random variable with a binomial variable. Well, in order to do that, you're going to take your n, your sample size, and multiply it to the percentage of success. And if it's greater than or equal to 5, and the n times the percentage of failure is greater than or equal to 5, then you can use the binomial distribution. If it does not meet this condition, you will not be able to use this to find the probability. Next, you want to find the mean and the standard deviation of using these formulas. The mean is made up of your sample size times your probability of success. Your standard deviation is made up of the sample size times the probability of success times the probability of failure, square root it. And then you apply the appropriate continuous correction, continuity correction. And that is either adding or subtracting the 0.5 from the endpoints. You're going to use the calculator to find the probability. And to find the probability, again, if you have a less than or it's shaded to the left, you'll use negative 10,000 for the negative infinity. You'll put the x value in, your mean, and your standard deviation. Greater than will take the lower bound will be your random variable, and then you use positive 10,000 to represent positive infinity. And then when it's between, it would be the lower value first and then the higher value second. So let's do an example. We have a survey that reports that 62% of internet users use Windows Internet Explorer as their browser. You randomly select 150 internet users and ask them whether they use Internet Explorer as their browser. What is the probability that exactly 96 will say yes? So now we're going through the steps here. I'm pulling out the information that's in the problem. I have 150 users. I have a probability of success, which is that 0.62, 62%. And then I find the probability of failure by doing 1 minus 0.62, which gives me that 0.38. Now I have all that information. I want to check to see if my sample size times my probability of success is greater than or equal to 5. And you see it's 93. And then my sample size times the probability of failure, and I'm seeing if that is greater than 5, and that also checks out. So therefore I can use this approximation to binomial to find the probability. So the next thing I'm going to do here is I'm going to find my mean by multiplying my sample size times the probability of success, which would be 93 here, and then you're going to find your standard deviation. The sample size times the rate of success times the rate of failure, and then you square root that value. So in this case we got 5.94. So now I have my mean and my standard deviation. Now I want to apply that continuity correction. When it says exactly, you're going to have it between. You're going to subtract 0.5 and add 0.5 to that. So we'll have a probability between those two numbers. So in this case it would be between 95.5 and 96.5. And now we can use our calculators. And because it's between, we'll put the lower number into the lower, the upper number into the upper, use your mean and then the standard deviation, and you'll find your probability. So the probability in this case would be 0.0591. So the probability of exactly 96 that will say yes is about 6%. This next example, we have 62% of adults in the United States have an HD TV in their home. We're randomly selecting 45 adults in the U.S. and we ask them if they have HD TVs in their home. What is the probability that fewer than 20 of these respond yes? So again, I'm pulling out the information. I have my N is 45. The probability of success is that 62, and failure would be 0.38, 1 minus the 62, or 0.62. Now I'm going to multiply the N to the P to see if it's greater than or equal to 5, and both check out here. And now I'm finding my mean, and my mean is that N times P, which is the 27.9, and my standard deviation, I will end up getting 3.27 or 3.26. So now I'm doing the continuity correction, and because it is fewer than 20, I have to subtract 0.5. So my random variable would be x is less than 19.5, or the probability of our x is less than 19.5. And then I'll put it into the calculator. It's getting shaded to the left, therefore it's the standard normal distribution table. So it's a negative infinity to 19.5. I put in my mean, my standard deviation, and I'll find my probability. And the probability here is 0.0050, which is a very low probability. Pause and try. So for exactly, remember to do that corrected interval, it's between 69.5 and 70.5, so you should have gotten a probability of 0.0841. For at least 70, the corrected continuity would be x is greater than 69.5, so your probability would be 0.4570 or 0.4569. And then lastly, fewer than 70, and fewer than 70 would be x is less than 69.5, so you should have gotten 0.5430 or 0.5431 based on what your calculator is getting, or how many decimal places you went with the standard deviation. Asking, identify any unusual events. Well, any unusual events would be probabilities that are less than 5% or 0.05. And therefore, when I look at all our answers here, none of them are considered unusual.